Hello and welcome. In today's sessions, we will talk about optimal weight cut. And this is a very interesting topic. And what we have done here, to give you some background, is that we have selected randomized controlled studies. So this is very important. This is controlled studies where they have been feeding people, or they have been asking people to eat in a certain way and perhaps also train in a certain way. And then they have measured weight loss, fat loss, lean body mass, and in some cases also strength. So this is not based on observational studies where you claim cause and effect, but since all the studies we have included here are controlled studies, we can actually claim cause and effect relationship. And for you that are perhaps statistical nerds, we have used something called reduced factorial designs, more specifically formulation designs. And we have also used something called principal component analysis. Okay, enough about that. Which factor have we investigated? We have investigated carbohydrates, protein, and fat. So these are the macronutrients. Then we've also looked at total calorie intake, which is calorie is a measure of energy. So it's more correct to say energy intake. But in the daily speaking, most people talk about calories, which is a measure of energy, just as joules are, for instance. We have looked at if they do any kind of training and if it, in that case, is cardiovascular or resistance type of training. If you look at these 6 factors here, and if you assume that you can have them on a low level, a medium level, and a high level, you can actually construct 729 different weight loss protocols based on these 3 levels. In reality, of course, these are continuous. You can have more than 3 levels of them, but if we stick to that as a practical measure. So the question then arises, of these 729 different weight loss protocols that you can produce, which one is best? Or are they all equal? Or is there one single factor that decides it all? Yeah, that is the questions we have been searching to get the answer for here. We will present that now to you. So first off, let's look at one of these factors. For instance, weight loss in relation to calories. And as you can see, there is some type of relationship here, even though it's fairly weak. But you can see when you cut calories, weight goes down. This is what most people claim to be the only reason for weight loss is calories. If that was true, this relationship would have been much stronger, I would argue. And the reason for that is that the explained variation here, which statisticians call for R square, is only 16%. That means that 84% of the weight loss can be contributed to something else than just purely how many calories people are eating. That is what this graph means. Okay, let's take another one. Let's look at body fat and energy intake. But this is strange. Here we see the inverse relationship. The more energy you take, the more fat you burn. Because this one was weight, total body weight, and this is just body fat, which usually is what you want to get rid of. But once again, this relationship is very, very weak. It's about 3% of the explained variation is explained. So basically, none of this tells you much about anything. The calories doesn't tell you if you will lose weight or not. That doesn't predict that very well. Nor does it tell you if you will lose body fat or not, because you don't want to lose body mass or lean mass. It's mainly muscle. Let's go to the next one. Let's look at body fat and carbohydrate intake. Now here you see a little bit better relationship. The lower you go in carbs, the more you lose body fat. And it's really body fat that we'll focus on from here on, not body weight. But once again, the explained variation is 35%, which is quite reasonable. It's a lot more than you have in observational studies. If you look at studies where they say fat is bad or cholesterol is bad, they don't have 35% explanation grade there. They are more like this, 3, 4, 5%. It's true, that's all they have. That is why they need to be 100,000 people in these studies to prove them statistically significant. Enough about that. 35% is not 100% either. You wouldn't expect to reach 100% because there's always some noise in the data. But still, there's more to do here. Obviously, body fat and carbohydrate intake has something to do with each other. This could be due to insulin, and some people claim that it's only not calories, it's only insulin that matters if you go up in weight or if you lose weight. Let's continue to look at the next factor. Body fat and fat intake. What do we see here? Well, what we see is that the more fat you eat, the more body fat you lose. Again, the explained variation isn't that high, it's only 14%. Now, it might be tempting to say that we are finished with our study here, because these are all based on randomized controlled trials. So what we see here are affected by these dietary interventions. And we have looked at fat, carbohydrates. We haven't looked at protein yet, but still. However, let's rewind a little bit. Look at what we're doing here. Because when we look at each factor like this, it's a little bit difficult to know, is it only this factor that influence it? We change fat intake, but you can see there's quite some variation here, because at different levels of fat or carbohydrates, the other settings are different. They aren't identical. That means that the variation here we see, why we don't get a model that explains more than just 14% or perhaps 35% here, is due to that the other settings are different in these different points. At low fat, low carb diet, for example, there's quite some variation. And that probably has to do with the setting of the other factors. So how do we build a map where we can kind of tie all these pieces together? Here I have some data for you. It's 40 data points from 2 variables. And 2 of these people here are different. Maybe they're sick, or maybe they managed to lose weight. What do I know? I just know they're different. And I want you to tell me which 2 that are different. And how would you assess that? When you look at factors like this one by one, you don't really see the full picture. It's very difficult to do that. If you look at both of them simultaneously, it's much more easier to see which 2 are different. So this is also what we need to do when we look at factors for weight loss. We need to look at them simultaneously. And more importantly, we need to build statistical models that does that. That is really the key. And once you have this model, you can create maps. It's like a puzzle where you put the pieces together and you get a map. And what we're going to do is that we are going to take these clinical trials and create a map instead, where we can see how all the variables influence weight loss. In reality, we do a statistical model or mathematical model, and from that we create the map. Simply because if I write a polynomial here, most of you guys wouldn't really kind of feel that you have got a map to the secrets of weight loss. You see some X and Y's and don't really understand it. But the map is easy to understand and more intuitive and gives a lot of. What we want to do with this type of map is to find the optimum spot. So you look at this map as you read the map, and this is a mountain, and here you have the top of the mountain. Or perhaps it's a valley and this is the bottom of the valley, depending on if you want to go up or down. We have created this map to reveal the secrets behind weight loss, because this has never been done before. That is why I use the word secret. For whom is this map valid? Well, it's valid both for males and female. It doesn't really matter that much. It's valid if you are, when you start to lose weight, between 16 and 50% of body fat. Age group in these studies has been from 24 to 56 years. Training has been quite moderate, from 0 to a couple of times, 3 times a week. Energy intake from 1200 to 2000 calories. We will highlight for you what happens if you go below or above these values also, but this map we're going to show is mainly valid in the average weight has been 94 kilos. But it seems not to be so. The map is valid for all. It's more that you need to be in the ranges of body fat. If you go below 60%, it starts to not be that valid, the map, simply because we don't have so much data from this. We only have a few trials that are below 60, but between 60 and 50 we have enough to say that this map is valid. BMI, the average is 34. Study time is important, it's 2 months. Not exactly, we have included studies from 8 weeks and 10 weeks also, which is close to 2 months. Health status, you can be pre-diabetic or not. Probably even have diabetes as well. This weight loss map is pretty much the same. Okay, so what have we found? How does this map look? Yeah, so this is the secret fat loss map. Before we go into interpretation, I will just explain how this map works. Because you can see that we have carbohydrates on this axis, fat here, and protein here. It's a triangle rather than a rather than the square that you usually have when you look at contour plot maps. The reason for that is that we want to see all the 3 macronutrients simultaneously. That's one reason. So how do you read this map? As you can see, I pointed out a dot here, this circle, and this circle represents 10% carbohydrates, and that you read by going out to the carbohydrate axis here. And you need to go in this horizontal direction, and that is the trick here. So you don't go in any other direction, because then you will read the map incorrectly. And then you can see that we have 60% protein, and that is read from protein here. And then you go on this 45 degrees angle. As you can see, the map also here is 45 degrees. So carbohydrates reads in this direction, protein in this direction. And that's important to remember when you look at this map. And then find a fat which is read in this downwards 45 degrees. So that is how you have a point here. You can see that it's 10% carb, 60% protein, 30% fat. And these will sum up to 100%. That is also one of the keys to this triangular map, that no matter where you point your finger at the map, it will sum up to 100%, which it should do, because people are eating these nutrients unless they are drinking a lot of alcohol as well. We didn't include that in the study. Then you might ask, why are there only colors here on part of the map? That is because the colors represent where we have data point to support the map. We can go outside the map and do extrapolations, but we only show you where we have high statistical significance. You see here the different colors. What do they mean? You can see there are some, if you look at the green area here, you see it says -4. It means that if you're in this green area, you're expected to lose at this border here 4 kilograms of body fat. The fat loss map, not weight loss, very important, fat loss, because that is what we want to focus on. We don't care so much if we lose body weight unless it's fat. So this green area here is 4 kilograms or more. So down here it's about 5 kilograms. Here you have 3 kilograms, the border for 3 kilograms. Here the blue, you are somewhere between 2 that you see here on the line. And over here you have -1 and then 0, no fat loss at all. And the same is true here. You have the same color here, green, which is 4 to 5 kilos, a little bit darker green, 3 to 4 kilograms of weight loss. And this blue that is from -2, which is here, to the borderline, which is -3. So 2 to 3 kilograms of weight loss. If you work with pounds, you just double this up and you have it. It's not exactly double up, but it's just a few 10%. You just double this up. So instead of saying the green is 4 to 5 kilos, you say it's 10 pounds of weight loss. Okay, so that means that there are 2 places where it's optimal to lose weight, and 1 place where it's definitely not optimal to lose weight. Let's look more closely at these 3 different spaces, because what this also proves is that calories is not the only counting here. Keep in mind that I say calories, and I mean calories in. I'm not saying that calories in and out doesn't matter if you were to measure them correctly. That is a different topics which we have been writing about on our blogs. I will not say more about that because you can easily talk an hour about calories in and out. That is thermodynamics. Here we only look at calories in, and these calories come from the food label, and they're not always that correct. So what we see here is the sweet spots. Let's start with the first one. This is based on 1600 calories diet. It is very valid from 1200 to 2000, as I said. So the percentages here will then be the same. 40% carbs, 40% protein, 20% fat. So it's a reasonably low fat diet, but also low carb and quite high in protein. If you are at 1600 calories, you have them in gram here. So that will be 156 grams of carbohydrates and the equal amount of protein and 34 grams fat. So it's a reasonably low fat diet. You also have a different spot that is at least as good or actually somewhat better, you will see later. But it's down here, and that one is even lower in carbs. It's on 8% carbs for 30 grams. Also much lower in protein, only 24% protein. And much, much higher in fat. So that means when people argue if high fat or low fat is good, they're both correct. Low fat, you can lose weight on low fat diets if they are reasonably low in carbohydrates also and high in protein. And you can lose weight or fat on a low carb diet. It can be moderately low, like this one, or very low, like this one. Is there one place you should never be when you try to lose body fat? It's here. 50% of your calories from carbs, 15 from protein, and 35 from fat. Do you know anyone who is in this area? Well, the average Western European or American is here. Perhaps also Asian, I don't have that data in my head. But anywhere where there is plenty of food, where people aren't starving, this is how we eat today. And you can see this white area here is quite large. Some regulatory agencies, some administrations, FDA and also the European ones, recommend you to eat often a little bit less fat, 30% fat, that is here, and more carbohydrates than perhaps 60%, and about the same amount of protein. But as you can see, it doesn't matter. The average Western diet and the recommended diet are both in this white spot where it's very, very difficult to lose any body fat. And in fact, if you're on a 1600 calories diet, which this map shows, you're not losing anything at all. You might even gain if you're unlucky. Now, there is so that this map doesn't consider cardio training or resistance training, but both of these has a very low impact on your fat loss. It has some impact, but it's very low. Resistance training is very important to preserve, to keep your lean body mass and to keep your strength gain, to keep your strength. But it doesn't really enhance or slow down fat loss. We also don't see the number of calories. It's constant. It's fixed at 1600 here. In the mathematical software we use, of course, we can put in any calories and see how this map changes. But it stays fairly much the same from 1200 to 2000 calories. That is why we put this limit as where you can use this map. Maybe you are, hallelujah, convinced, or maybe you're not. It doesn't matter. You should always validate your findings. We have done this with statistical model, and now we will do it with this map, since we prefer to talk about maps and navigation rather than polynomial mathematical models and standard deviations and so on. Let's see if this map holds true. Let's look at some real data and see how they map into this space here, interpret them. First out here is a weight loss study where you can see the raw data here. Fat is 121 for the low carb group that did some exercise. And here is the group that were eating just the average diet, but also did the same type of exercises. You can see the carbohydrate content, 23 grams towards 186 and so on. You can also see that they did take some alcohol, which skew things a little bit, because this map isn't built to contain alcohol. It's supposed to add up to 100% if you take fat, carbohydrates, and protein. But still, it adds up to 90 plus something, so it's good enough. If we take these values and put them in this map, one group will end up here on the average diet, doing all exercise, and the low carb group doing exercise will end up here. So this map predicts then about 1 kilograms perhaps in weight loss here, and probably around 5 kilos for this group. What did they actually achieve? Is this map telling the truth here or not? You can also see on the calories, they were above 1600 calories. One group actually close to 2000 and one was 750 about. But as I said, it doesn't have too much impact. It has some impact, but it's not that much. We are in these 1200 to 2000 calories that we claim the map is valid for. What did they achieve? Yes, so this group here achieved not really 1 kilo, but 0.7, and that is where they end up. They are between 1, -1 and 0, probably right on 0.7. Maybe we were a little bit lucky almost. And this group here did 5.6, and the model actually predicts about 5, so they lost a little bit more than the model predicts. So they did do some exercise here, so that could be the explanation why they lost a little bit more than the model predict. On the other hand, this other group didn't lose more, but they were also eating a little bit more calories. Pay attention to the way here that this group that lost 5.6 kilos did eat more than what the map shows. In the software, you have to choose what calories to show the map for, and it looks very similar from 1200 to 2000. So that is why we have that as a range of validity for it. So clearly here, these two spots seems to work very well. What the map say you will achieve in weight loss during 2 months is what you actually will see in real clinical tests. But to validate the map and also to continue to teach you how the map works, we continue with more examples. Here is a study where they have looked at 3 different protocols simultaneously. And they call them high carb, high protein, and high fat. As you can see here, they are not that extreme. None of them are very high in carb or very low in protein or high in fat. And that is important to remember, because often when you read about high carb, high protein, high fat, you better check exactly what the values were. It's not always they are that high or that low as they claim to be. Well, what did the map say here? How does it correspond? They did do below 1600 calories, and they also did cardio on that. So you might expect then perhaps that they have lost a little bit more weight than this map predict because of the lower energy content and addition of cardio. And in fact, that is true. They did lose more weight. The map is a little bit off here. 3.4 for this group. The map only predicts about 2 kilograms. 3.1 here, the map predicts between 2 and 3, so a little bit above. And it's the same for all groups, that they lose more. Here the model predicts 3.5 and it was 4.4. So about 1 kilo more of weight loss for all of them. It could be something specific with this setup. This particular people was chosen for this. But also you see the energy is a little bit lower, and they did cardio training a couple of times a week. That speeds up the fat loss somewhat. However, as we will see later on, we will also include the lean body mass here. Just doing cardio without resistance training, even though it do speed up weight loss and fat loss, it also breaks down muscle tissue. And that is not good in the long run if you want to lose body fat. So you see it's still reasonably well. Here the map works reasonably well. Let's look at one more. So this is people doing high protein and resistance training. What we try to do here is to pick different points of the map to make sure that the entire map is valid, and also that they are on different calories and different training protocols, to give you an understanding for how you can trust this map and when you perhaps cannot trust it. Here you can see once again, they are exactly on 1600 calories they claim. I say they claim because it's difficult to assess. And you can see they lost 1.7 kilograms of fat, a little bit more than the model predicts. And the same, this one is right spot on. It predicts between 3 and 4, and where they are, 3.4 is pretty much exactly what you can expect. So once again, also for this protocol, the weight loss map seems indeed accurate. Sure, it can deviate half a kilo, which is a pound here and there, but still it gets you the correct ballpark number. One more here, and here we go a little bit more extreme. One here of the diets is actually very low in carbohydrates, and it's also, it's very low in energy, in calories. It's only 700 calories, and we said that the map mainly is valid from 1200 and up to 2000. Here you can see it's a little bit off. They lost 4.7, and the map predicts, perhaps 3.5, so more than 1 kilograms, more than 2 pounds more in fat loss. And for the other group, it's also a little bit more, perhaps half a kilograms more in fat loss than the model predict. But what you can see here also is that these protocols, if you look at the total body weight, has not been very good. Up here, the very low calorie group, they lost 13 kilos of weight and only 4.7 kilos in body fat. So that means they have lost a lot of lean tissue. And if that lean tissue is muscle, which is to some extent for sure is in this situation, that's not good, because it means you will not be able to keep this weight loss off. Because your energy goes down, your metabolism goes down, because that very much depends on your muscle mass. Also, the other group lost a lot more weight than they did lose body fat. But we will soon come to the lean body mass, and then you will see that this area is not only poor to lose body fat, it's also poor if you don't want to lose muscle mass. So once again, the map gives you the right ballpark number. Perhaps it's a little bit off, but in this case it's understandable, because in one of the trials, they are in a very low calorie diet, and we have very few experiments down there, so we can't really. I can show you that picture. It looks similar to this one. You just lose a little bit of weight. Slightly different, but statistically you will need more experiments to validate that it actually is solid in that low calorie area. But one other reason why we didn't continue that investigation is that we saw right away that if you want to lose body fat and not lean mass, you shouldn't go down that much in calories anyway. So it's not that much of an interest to be down there. One more validation point, and here we have you can see that they have lost more than the model predicts. 3.8, the model predicts 2, so it's almost the double. And the same down here at 4.2, the model predicts perhaps 3. One reason for that is that this study was 3 months and not 2 months, and then you lose more. If people are strict to the diet, they usually you can actually take the number you get from this 2-month study and multiply it with, and you will get 3 months weight loss. The same is true for 1 month. You can divide it with 2, and you will get a reasonably good prediction of the 1 month weight loss. One thing I want to point out here is these two groups lost almost the same amount of fat mass. And according to the prediction of this map, it should be reasonably similar. This group here at 4.2 should lose a little bit more. Even though both lost more than predicted, because the study time was longer and perhaps because they were a little bit lower in calories also, in particular one up here were below 1600. You can often hear people talk about that the only thing that matters is calories, and then they have references to studies where they've looked at, for instance, low fat, high fat, low carb, and so on. And these studies show small differences, maybe not statistically significant. And you can find a handful of these studies. And then you can collect all of them, and then you can make the statement that it doesn't matter the macronutrient ratios, you lose the same amount of body fat. It's just calories that count. But what all of these have in common is that they are in this blue area here, where the model say or claim, predict that there shouldn't be any real difference in weight, in fat loss. So you can set up a study low and high in fat, which go into these green areas, and then there will be a dramatic difference. Or you can set it up so that it just moves along in this blue area, and then there will not be any difference. And the same for carbohydrates and for protein. So that is why we have 2 or 3 different sides out there that say, I'm for, just calorie counting. Because they look at studies that aren't supposed to give any difference according to this map. You have low carbers who only look at studies that are low carb and truly low carb, and then you lose more weight. You have low fat people, and yeah, you can. If you compare with something here and go low fat down here, you will lose more body fat. Particularly if you also go down a little bit in carbs, then you might even reach this sweet spot, which is low fat, just 20% fat. But it's also moderate in carbs. So they're all right, but in the same way, they're all wrong, because none of them give you a true picture of how this all looks together, because obviously it cannot be so that hundreds of studies on one side are falsified or wrong, and 100 studies on the other side are wrong. Scientists aren't that stupid when it comes to research. It simply is because they are in different places on this 3-dimensional map. And this is just one example of that, how we can see that if someone claims there is no difference, look at the numbers exactly. Was it really low carb, or was it really very low fat? Exactly how was it put together? And match that with this map. Okay, the next step here is that you want to lose body fat, but you do not want to lose muscle mass. Because here we look at body fat, which is better than look at body weight. But still, it doesn't say anything about muscle mass. So what we have done here, we have asked this software, which is called Modder, by the way, is there a way for me to lose as much body fat as possible? And we set the limit here. I want to lose 5.5 or 5.8 kilos of body fat. But I do not want to lose total weight more than 7.5 kilos. So that means I can lose 2 kilos for pounds of water, but not more, because then there's a risk that this is muscle tissue I lose. If I want to lose as much body fat as possible, but keep as much muscle as possible, where should I be then? And what you see is something called a sweet spot plot. The yellow area here shows one of the criteria is met. Either that you lose enough body weight in total, or that you lose enough body fat. But not both criteria met, which means body fat only. that is only valid in this purple or pink, spot here. And now you will say, oh, that's a small spot. How can I hit that one? Well, the reason for it being small is that I have enhanced the criteria. If you say I accept to lose 4 kilograms of fat, it will be much larger. But I've enhanced the criteria to see what is the maximum I can lose in 2 months. Well, that's 5.8 kilograms of body fat without losing any muscle mass. Then you have the sweet spot. If you loosen the criteria a little bit, the sweet spot will be larger and larger. And in fact, it will also turn out that both these spots, the green here, but also this one, is good for losing body fat. You don't need a separate map to see where you can lose body fat without losing muscle mass, because these two are at the same place. And the opposite is also true for the worst place to be, which is over here, the area which your food agency recommend you to be. That is the worst place also if you want to keep your lean mass. If you just cut calories there, you will lose very little body fat and a lot of muscle tissue. Sure, training is very important. If you do resistance training, that has a lot to do with it. But with that or without that, the map looks the same. It's just that you lose a lot more body tissue if you don't do the resistance training. So let's look at some data points to see if this is supported as well. Let's go back to this study where they lost only 0.7 kilograms here as predicted and 5.6 kilos of body fat here. But what about lean mass? This is how it looks. They lost, you can see, fat mass, as we said, 5.7 kilograms in the low carb group, which is called something called ketogenic when you're very low carb and high fat. The other group almost didn't lose anything, and it's not even statistically significant. These are significant levels. So they lost the fat, which we said, but what happened to lean body mass? Yeah, very interesting here. So these guys, or women actually, they were resistance training. They didn't lose any lean body mass. They only lost body fat, nothing else. The other group, however, they actually gained some lean body mass, which is normal if you do resistance training. But they didn't lose any body fat. So you can see that this map is not only valid for weight loss as such, but also if you want to lose weight without losing lean body mass. One thing to point out here, that sometimes you do see, in particular, ketogenic studies where they lose a lot of body weight if they are longer term and if people are very obese. Does that contradict what we see here? Not really, because there is 2 ways you can lose lean body mass. One is that you actually lose muscle tissue, and which you can see here, they didn't do that. If your lean body mass decrease, it might be because you lost muscle tissue or that you lost body water, fluids. And this happens when you have usually very obese people and you look at the inflammation markers. They are inflamed. They have inflammation in the body. And that ties up water. You lose water when you lose carbohydrate, but you only have a couple of 100 grams of carbs that you will lose. You maybe have a half a kilo, but the body will never deplete itself totally for carbohydrates. It will keep 1/3 of that at least, and usually 2/3. So it means that you don't lose more than 1.5 or 2 kilos, that is 4.5 pounds of water and carbohydrates together. If anyone loses more than that, it either is muscle mass or water due to inflammation. And we can see when inflammation markers change dramatically, we also see these 10, 15 kilos, 20, 30 pounds of lean tissue decrease, but it is water, it's not muscle mass, which you can verify by, for example, looking at strength. There are other ways also. But what the model does here is that it doesn't exclude them, but it looks for a way to lose body fat with keeping preserved lean mass. And the best way to do that is the ketogenic diet. And the second best is this moderately low carb diet, which is also low in fat and high in protein. Here you can see the individuals in this study, how you can see the red ones here, how many people, some people lost fat mass, you can see here, but they lost also a little lean body mass. Some of them did lose a kilograms of lean body mass, but also one of them lost 10 kilograms of fat mass. That's a lot. You can also see that some people increased their lean body mass. So this indicates that they got stronger, more muscular at the same time as they were burning fat. They lost 6 kilograms of fat and added muscle. You can see here on the other group, no one is even close to this. No one, the best fat loser in the high carb group, didn't even beat the one with the worst outcome, or the poorest outcome, I should say, still good outcome, in the ketogenic group. So quite some difference. Dramatically difference. Let's also push this a little bit longer. Here is a study on elite gymnasts. And we said this picture is true for moderate exercise. If you go to elite exercise, it will change a little bit. Still though, as you can see here, the predicted is actually right spot on for this group. It predicts 2 kilograms and they lost 1.9. And these guys lost 0.2, which is what is predict. But I have to confess the model is a little bit lucky here. It will not perform this well on all types of when you go outside the boundaries, because they're elite training and also they're very, very low. If you look at the starting values here, they start at 5 kilograms of body fat and drop down to 3 something. This is only 8% of body fat, and they went down to 4 or 5% of body fat. And our map is valid from a little bit higher numbers, 14, 16% starter becomes valid. So they are off in two ways. They're off because they trained too much and they were too slimmed when they started. These are elite athletes. Still, the map is valid in such a case that it's still the same areas that you should avoid and stick to, but they do change a little bit. Because when we do this validation, we don't want to show you only when the model is 100% accurate. We also want to show you how it can deviate and why, so that you can take that into account when you interpret your own situation. And the reason why this is also a good study is that they looked at strength and they didn't lose any strength while they went down this amount of body fat. They cut about 1/3 of the body fat and didn't lose any strength. And that once again validates our model that the best way to do that is the ketogenic diet. Second best up here, and totally worst it is here in the white area. One thing to point out here is that if you read this study, you can say they were on the ketogenic diet, they were in ketosis. For normal people, you need to be on these macros that are green here to be in ketosis. That is, that you produce ketones, beta hydroxybutyrate in the blood, then you're in ketosis. But when you train a lot, you can eat more protein without being thrown out of ketosis. So if you are down in this green spot here, you can increase protein if you train a lot. As long as you stay in ketosis, you are in this green spot. This green area actually looks like this for an elite athlete that trains 10, 15 times a week. You can eat much more protein then, even some more carbs also. So as long as you are in ketosis, you are in the best spot. It doesn't matter if you eat a little bit more protein or so, as long as you're still on ketosis. And that was also something I wanted to show with this, by including this study that is a little bit off in many ways. And the same is true here, that you can go up in carbohydrates if you're an elite athlete. You don't need to be 150. You might get away with 200, even 250, and still be in this green zone. So the map do twist. It turns in the right direction up here and goes clockwise down here when you go from normal people to elite athletes. But essentially, you have these two good zones and this devastating zone. We can see that here also. They lost a little bit fat mass, lost exactly the same amount of weight as fat. Whereas in this group, they actually lost more fat than weight. Despite being on a diet, despite losing 1/3 of the fat mass, they actually increased somewhat in the lean tissue, which you can see reflected here. They didn't lose any strength. And some of these strength tests, many of them were tests where you did 20 repetitions, and the low carbohydrate diet in itself can be a little bit inhibitory there, because you do use carbohydrates when lactic acid is formed, which is formed if you do 20 repetitions. They did, for instance, chins 25 repetitions and so on. Quite heavy stuff. So if you only would have tested maximal strength, they might actually even have increased a little bit. But most tests here were for quite a number of reps, simply because that was relevant for gymnasts. They don't do bench press 1-2 times. They perform for a couple of minutes and need to be strong during that entire time. So how do we wrap it up here? Now we have done all types of validation for people that do cardio training, for people that do resistance training, people that don't train, people that eat low carb, high carb, low fat, high protein, low protein. Pretty much we have been all over the map and seen that it indeed do very good prediction in the expected weight loss. We also tried different calories, low calorie and a little bit higher calories. You can see this for example, they are eating more calories, but since they're elite athletes, they are still deficient here because they train so much. So to round it up, this is where you should be and where you should not be. And I think use this map, look at your macros first. If needed, you might need to look at calories also, but many people, when they just look at macros, and the thing is, if you look at all 3 macros, you lock your calories. But if you, for instance, go for ketogenic diet, which is the best one to lose body fat and to keep muscle mass, even increase in some, half of the individuals did in the groups here, and also decrease inflammation. It's good for many things. We have a follow-up, by the way, called 7 questions about ketogenic diet that you might want to watch if you want to read more about ketogenic diet. We also have a different option. Not everyone likes the ketogenic approach. You go high protein instead, low fat, but not too much, moderating carbs also. And it's not a coincidence that this one is 150 grams in carbs and this one is below 50. Often it's said that below 50 you become in ketosis. The magic number about 150 is that if you're not in ketosis and decrease carbohydrates, your body, your brain uses glucose and some nerve cells and some red blood cells, erythrocytes as well, and they need about 150 grams carbohydrates. So if you go below that number, the body will then take protein and turn it into carbs because it can't use fat for that, at least not fatty acids. Then, if you go all the way below 50, what happens is that the brain would start to use ketones. And basically all the body can use ketones, probably except some cancer cells, which is good if you want to get rid of cancer. But otherwise, pretty much all cells, 99% of them at least, can use ketones. For still red blood cells, I think they need carbohydrate, but they could also use glutamine or something else. But anyway, what happens here then is when ketone production starts, you don't need 150 gram carbs suddenly. You can cut that with at least 100 grams. The brain will still use some carbohydrates, but 2/3 of its energy will come from ketones if you're in real ketosis. And all muscles and everything else can use fatty acids. They love that. As soon as you give them fat, they will eat fat. They only stop with that if you give them carbohydrates. Then they go back to fat as soon as they can. Unless you insist on training them to eat carbs, they forgot how to burn fat. Then they will instead burn protein when they don't get fat, because you can turn protein into carbs. So that is the biochemistry behind this. But that we cover in Black Belt Nutrition, and the web page. It's a lot about that. Here we try to focus just on the clinical outcomes. What I want to say is that the clinical outcomes fits perfectly with the biochemistry. There should be a little bit kind of a bump at 150 grams. And if you remember, if you go back to the first picture, if you remember when we looked at this first, when we tried to do this univariate interpretation, which you shouldn't do, look at them one by one like this. If you look at carbohydrates here, you can see how it goes down, but between 50 and 150, if you draw a straight line here, there's no decrease at all. It goes down here, then it bumps and flats, and then it goes down again. That's exactly what the map shows, how it goes down at very low carb, it's flat in this area, and then actually it's better to be above 150 than in that case. You can't make that interpretation from this just one plot. That is why we have to put everything together to make a multi-dimensional plot that shows everything simultaneously. and more importantly, to use statistics that test everything, build models of everything simultaneously. Then you get this map. I just wanted to connect it with the plots we saw, because all of these plots will make sense if you look at this map, why they sometimes are deceptive. So I think this is this. Now you know how to use this map, use the map, and keep in mind, go through this again. You can see some deviations. We explained why. If you do cardio, if you cut calories too much, if you're elite, training more than 3 times a week, and also how hard you train has some influence on it, of course. So this is this. Now you have learned the secret to fat loss, and probably also you have learned why so many studies are claimed to be contradictory, simply because they really aren't testing what they claim they are testing. There are no contradictions actually. Please go into Black Belt Nutrition, and we have plenty more things there. We have topics about ketogenic diet, we have about strength training, we have links to a podcast, Superhuman Radio, where we talk about strength training, how to gain strength as fast as possible, and many, many other things, calories in, calories out, you name it. And we also have the big thing, which is educational material, which takes you to the black belt level in nutrition and training. It is like 13, 14 hours long. That one you can purchase. If you do that, you support future research. We would like to put these things in a smartphone app so you can put in your exact values and get out exactly how to train to gain strength, to lose body fat, to improve your health in other aspects as well. So please go in here, read more material, or purchase something to support our future research. Where what we do is that we take research from the research to the public. We don't do reports from researcher to researcher. We do them from researcher to the general public, which is very different compared to if you read on PubMed yourself. That stuff there is meant to be read by other researchers. Okay, thanks for this time, and please visit our website.